Hello everyone. Now let's talk about quickly few special type of circuits. So if you're talking the special type of circuit, the first circuit is this is called as Wheatstone bridge. Now here we can say one, two, three, four, five. Five resistor are there. So if the condition is VA is equal to VB, so we can say this capacitor has to be removed. I repeat, if VA and VB both potential are equal, so in that case once it will be removed, C1 and C3 will be in series and C2 and C4 will be in series, and these two are in a parallel, through which we can calculate the resultant capacitance. Fine. So here we can say C1 and C3 in series, the whole C1 and we can say C2 and C4 in series, and these two are in parallel. So by this way we can calculate. Now here we can say this is very much replicating. Again, if there are five capacitor or resistors, C1, C2, C5, C, so 1 2 3 4 5 resistor or 5 capacitor are there, so we can say this capacitor, that is very similar to the previous situation. We can rearrange to C1, C2, so here we can say C1, fine, and that is C2. It will be connected with C3 and C4. So this is look like series and both will in parallel, so we can calculate. Now let's quickly get back to this is called point potential method. Let's say here potential is V1, so it will also V1. Let's say this point potential is V2, so what will happen, this potential will be V2. So in that way we can say V1 minus V2, V1 minus V2 and V1 minus V2. These three are in parallel, and this will be in series with C4. So we can say 1 2 3, and this is series. Through this way we can calculate this type of capacitor arrangement. Now next it is called as ladder circuit. So here we can see repeated unit. So if we have draw a vertical line here, we can say C 2 farad 2 farad 2 farad 2 farad, it will be keep repeating itself. That means we can remove this assembly and we can add some X. So our new circuit will be become this much. So X and 2 farad will be in parallel, and then it will be series with 2 microfarad, and then we can calculate the resultant will be equal to X. So the resultant circuit will be we can say X plus 2 microfarad, and it will be in series means we have to multiply 2 farad the whole divided by X plus 2 plus 2, that should be equal to X. So with the help of this equation we can calculate the value of X. That will be your final answer. Fine. Now these are three. Next circuit, that is called inverse symmetry. Now inverse symmetry, here you can see, let's say total current Q it will come. So 2 and 2 connected in a opposite manner. Here you can say 4 and 4 are connected with opposite manner. So we can say this is called as inverse symmetry. Inverse symmetry, let's say total Q it will come. So let's say here it is flowing Q1. So Q minus Q1 flowing. So same capacitor, same charge will be flowing to here as well. It will be flowing Q minus Q1, and here it will be flowing Q1. I repeat, same capacitor, same charge, it will be flow. So what about the charge? It will flow in the middle part. So we can say Q minus this one. So Q minus Q1. This is a flow through this branch. Now we can apply simple loop. Now let's say we have connected with some battery E. Fine. So we will apply one loop in the given mesh, and one we will apply in the given mesh. So with the help of these two mesh, we can calculate, as you know, Q is equal to CV. So let's say Q upon V ratio, that is equal to C, and C will be the total resultant capacitance of this circuit. So I hope this is clear to you. Now next, that is called as point symmetry. Point symmetry means here we can say A and E, we have to calculate the resultant. So let's say at a distance 1 unit. So 1 unit is H, at 1 capacitance unit B. So here I am writing from A, B and H. B and H, this is 1 capacitor unit apart. Why I am saying this symmetry point? Because after A, this is 1 capacitor unit, and once we calculated E, so we can say 1, 2, 3. Here 1, 2, 3. So this is symmetric point with respect to E, and this is symmetric point with respect to A both. That's why here I am writing BH. Now next, 3 capacitor unit. We can say 1, 2, 3. Point is D. Here 1, 2, 3. Point is F. Fine. Or we can say 2 capacitor unit first, then 3 we will see. So 1, 2. So G point will come, 1, 2. C point will come, or here we can say 1, 2. I point will come. Isn't it? So here I am writing C, G, I. And this point is also symmetry with respect to E. Here you can calculate 1, 2, 1, 2, and 1, 2. So from the both end, transmitter, receiver end, this will be also symmetry point. Last is 3. So 3 means 1, 2, 3. That is point F. Here 1, 2, 3. That is point D. And here you can see from receiving end 1, 1. So this is also symmetric point. So here we can say these are symmetric point, and how many capacitor are there we can calculate, we can connect. So here how many are there? We can say 1, 2. Now here how many capacitor are there? 3. So we can add 1, 2, 3. And how many are there? 2. 2. And here we can say how many are there from D to E. So like E, it will be G, H, E to F. Then how many are there? So it will say 2. Now look like very simple, parallel, 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 and all are in series. Now we can connect and we can get the answer. Fine. And the last circuit, that is called as a mirror symmetry. Now mirror symmetry, here if you will draw one parallel line, this whole segment will be symmetry of this line, that is called mirror symmetry. And very interestingly, the mirror symmetry, the line passing through it, you can disconnect it. You can disconnect the whole current, it will go, same current it will flow here. So this will be disconnected. So these two are in series and parallel to it, and here this will be series. With the help of this combination we can connect and we can calculate the C equivalent. So if you are looking for any other description, so you can ask, I will make the video on it. I repeat, symmetry circuit number 1. Second, you have seen point of symmetry, inverse symmetry, ladder circuit, point, potential method, and this is Wheatstone. Thank you.